This is the screencast for section 2.5, example 3. We're going to do the same thing in example 2. We're going to find a polynomial from the given zeros, but this time it looks like we've got two different imaginary zeros. So I'm going to start by writing out if 1 is a 0, x minus 1 is a factor. Then if 1 plus 2i is a 0, not only is, okay, so then we have got x equals 1 minus 2i is also a 0. So the factors would be x minus 1 plus 2i and x minus 1 minus 2i. We've got another 0. X equals 1 minus I, which means x equals 1 plus I is also a 0. So those two factors then created with those zeros are x minus 1 minus I and x minus 1 plus I. Woo! Wasn't that exhausting? All that algebra. Maybe you took a nap, I don't know, but basically I did all this algebra feeling that I showed you a lot of that in example 2. Go ahead and read through this, see if you can see how I did every step. Feel free to try it on your own and see if you got the same thing. This type of problem would not be unreasonable for me to ask of you on an assessment. There is a lot of algebra involved in these few sections here. Now I'm going to graph this on the calculator and see that the graph only crosses through the x-axis at x equals 1. And there it is. The now try problem for example 3 is number 13. Write a polynomial function, again, of minimum degree in standard form. So yes, you have to multiply all that out with real coefficients whose zeros and their multiplicities include those listed. So I am going to first write out the factored form of the polynomial. So if 1 is a 0, a factor is x minus 1. Now that's multiplicity 2, which you could write as squared, but you cannot distribute a square. I'll show you in a second. Negative 2 is also a 0, so that's x plus 2, or x minus negative 2 is the factor, with multiplicity 3. So really what I'm dealing with in this problem is y equals x minus 1 times x minus 1, so x minus 1 squared, and then x plus 2 times x plus 2 times x plus 2. So there's all of my algebra. What an adventure! I graphed in my calculator my final answer after the very last step, and I can see that, so negative 2 is a 0 with multiplicity of 3. Since it's an odd multiplicity, the graph will cut through the x-axis at negative 2, which it does. Now positive 1 is a 0 with multiplicity 2, so the graph is going to bounce off the x-axis at positive 1, which it does. This is an odd degree polynomial. It's actually degree 5. As you can see down here in standard form, after I multiply all that out, I have a degree 5 polynomial. So the end behaviors are opposite, the left one going down, the right one going up, because the k value is positive.